You all are welcome to my channel Maths Guide, and today we are going to discuss one important lesson in mathematics field, especially in A level, Cambridge A level, National A level. This integration lesson is pretty important. Therefore, today we'll focus on integration part of mathematics with the basics. So basically, integration is somewhat the opposite operation of differentiation. In differentiation, what we do, in integration, we do the opposite of that. But there are some important things when you follow up the opposite process of integration. Therefore, we need to have some rules. We need to know what are the basics, and we need to know exactly what are the special notations which are going with integration. So then this is the basic idea, right? So look at this example. Let dy by dx equal to 2x. Can you guess what would be the function y if integration is going to be the opposite operation of differentiation? You might guess that will be x square, right? Why? If you differentiate x squared with respect to x variable, you get dy by dx equal to 2x, which is same as this what they have given. But the other important thing is that only the function that we can differentiate to get 2x? No. So if you look at this, what about y equal x square plus 1? If you differentiate x square plus 1, still you get what? 2x. Because when you differentiate a constant value, that becomes 0. Then, if I look at this, y equal x square minus 2, same, right? If you differentiate x square minus 2, x square will be 2x, while minus 2 becomes 0. That means we can differentiate different types of functions to get the same answer 2x. Then how can I find out when I integrate the 2x term which one of these will be my correct answer in integration with something else? Let's see. So this is another example. If you differentiate y equal x square plus 3 over 4, still the answer will be 2x. Therefore we have a kind of a issue there to find out what is the function coming when you integrate 2x. So let's see. This will be my conclusion. According to the previous example, you see that many possible functions for y when dy by dx equal to 2x and when integrated that. So other special thing about this thing is this x square term is common. This x square term is common for each and every expression that you guess there. Therefore, x square will be there in the function when you integrate the 2x function. Other than that, all the other terms which were there in the possible functions were constant values. 1, minus 2, 3 upon 4, those are going to be constant values. Then, in integration what we do, we add that the constant value as an arbitrary constant value. Why? Depending on the situation, that constant value can be different to each other. Therefore, we define it as an arbitrary constant and denoted it as equal c. So, if we summarize what we have done so far, when you integrate dy by dx equal to x function, you get y equal x square plus z. You get y equal x square plus c there, which is c is going to be the arbitrary constant value. So we define this as the general solution of the differential equation. Dy by dx is 2x equal to 2x is going to be a differential equation. Then y equal x square plus c, which was the answer of integration of the differentiation function. Therefore, we tell this as a general solution y, this c is going to be an arbitrary constant value. Depending on that, you might have different answers, different functions. That's why this becomes a general solution. So actually dy by dx equal to x is an example of a differential equation, and the process of solving this differential equation to find the function y is called as the process of integration. So I think now you have a clear idea about what does it mean by this integration and what we are going to do under integration. Then next part is particular solutions. Previous answer we got a general solution, but most of the time we need to have a particular solution, a certain solution for a given differentiation equation. Then we can do it in this particular order. They will give you dy by dx is equal to what? What is the differential function? They will give you that. As well as they will give some additional information to that. That means that additional information will be helpful to find out what is going to be the arbitrary constant c value. For an example, it is given that dy by dx equal to x, and when x equal 1, y equal become 2. So they have given the differential function as dy by dx equal to 2x, and x become 1 while y become 2. That will support to find out the arbitrary constant value. We already know that the general solution for dy by dx equal to x is going to be y equal x square plus c. Then we can come up with a particular solution by substitution of x equal 1, y equal 2 there. So I substitute x equal 1, y equal 2. So 2 equal 1 square plus c, which will result to get c is equal to 1. Finally, we can substitute the simple c value, this arbitrary constant value, as plus 1. So we have a particular solution for this differential equation as y equal x square plus 1. So this is the complete process of integration to get the function when they have given the differential function. Let's go forward. Then with the support of previous example, we can get an idea about a rule. You can form up a formula or a rule for the integration of functions with x to the power n. That means if you have a power of x, we need to have a particular formula for the integration, and that will be this. So if you look at y equal x to the power n plus 1 function, if you differentiate that, that will be dy by dx is equal to n plus 1 into x to the power n. So what is the process of differentiation? You take this power or the index term to the front of the function into reduce the power by 1. When you reduce the power of n plus 1 by 1, this becomes n, so it becomes x to the power n. Then with the support of these two answers, we can guess that if the function is y equal 1 upon n plus 1 into x to the power n plus 1, dy by dx going to be x to the power n. That means, in opposite way, if I integrate this function, my result will be this. So we form up the final rule just like this. Whenever you have the differential equation as dy by dx equal to x to the power n, the answer of the function will be 1 over n plus 1 times x to the power n plus 1. Increase the power by 1 of the x term, divide by that particular power. That will be the answer. So this rule is valid for any value of n, for every value of n other than minus 1. It is obvious that if you look at the final function answer, if this n value becomes minus 1, this will lead to minus 1 plus 1 becomes 0. So denominator becomes 0 is not going to work. Why? We don't get a finite answer, a real answer. Therefore, we can't use this formula for n equal minus 1. any other value is quite fine. So I'll give one example to try myself. This is the example. Let dy by dx equal 3x square plus 4x plus 3, given that the point 1 comma 3 lies on the curve. We have given the differential function as 3x square plus 4x plus 3, as well as given that the point 1 comma 3, x value 1, y value 3 lies on the curve. So this will lead to get the answer just like this. First part is find the general solution of the differential equation. General solution means in terms of the arbitrary constant after integration. After that, find the equation of the curve. That means we need to find the value of simple c with the support of this coordinate. So by integration, if I integrate this particular differential equation, dy by dx become y, as well as 3x square become 3x to the power 3 divided by 3 plus 4x square over 2 plus 3x plus c. Don't forget this c, where c is an arbitrary constant. Just a simple simplification there. We can cancel off this 3 by 3, 4 divided by 2 become 2. Then the final answer of the general solution of this differential equation becomes y equal x to the power 3 plus 2x square plus 3x plus c, where c is an arbitrary constant. So this is the complete solution for the general solution of differential equation. So we are done with the first part. Second part, we need to find the c value. Substitute the coordinates of 1 comma 3x become 1, y becomes 3. So when you substitute that, you will need to get the value of simple c as minus 3. Quite easy, just a simple substitution there. So final answer, the equation of the curve becomes y equal x to the power 3 plus 2x square plus 3x minus 3, y equal x cube plus 2x square plus 3x minus 3. So this is the equation of the curve. I think you got an idea about what is this integration process as well as how it is managed. So don't forget this important part. First part is they will give you the differential equation as dy by dx equal to a certain function of x. Then apply integration, opposite operation of differentiation. Then don't forget to add that arbitrary constant value simple c there. Then they will give you an additional information for you to find out the value of that simple c. Then after substitution to the general solution that you derived by integration, you can find that arbitrary constant value simple c. Then after substitution to the general solution, you get the final function of the curve quite easily. So that's the main part of integration and the basics of integration, the first formula that you will be applying for the integration process. Okay, then I will give you some questions to try yourself. So these are included in my video. You can try, comment the answers if you wish, or if you find any difficulties to find out the solutions according to these questions, just let me know so I can give support for you. So this is another question. I have provided the answer as well. So this will be another set of questions as well as one more. So that's all what I want to discuss today, and this is my first video of integration. My next video will be about the integration of functions as well as finding the area under the curves. That is a very important result. And how do we derive the formula to find out the area under a curve, and notations of integrations and practical applications of integrations. Those will be discussed in my next video. Then thank you for joining with my video. Enjoy my other videos in the channel.